All right, today we're going to move into lesson 1.7, which is on midpoints and bisectors. The objective day is just to, understand the definitions of both midpoints and bisectors, how they relate to one another, and then some applications of really finding midpoints on both a number line and in the coordinate plane. All right, start out with the definition of midpoints here. Okay, the midpoint of a segment is the point that's halfway between the endpoints of the segment. It's an equal distance from the endpoints. So once you get to the midpoint, it's an equal distance from that midpoint out to each of the endpoints. And then the midpoint separates a segment uh, into two 1-to-1 ratio segments. So the midpoint divides it into two equal parts, if you will. All right, when we find midpoints on a number line, okay, the process is pretty straightforward. What we're going to do is take the average of the endpoints. So the M stands for midpoint. So the midpoint is take my two endpoints, x1 and x2, let's say, add them together, divide by 2. The answer to that is where the midpoint is located. So if we had this number line, endpoints A, B, C, and D were located at the given points, and you were asked to find the midpoint of A, C, the process then would be take the point values, or I should say values here, the locations of A and C, add them together, -8 plus 3, divide that by 2. So -8 plus 3 is -5. -5 divided by 2 is -2.5 or -2.5. So the midpoint of AC is -2.5. So now all these definitions up here apply to it. So M is an equal distance from A and C, and it divides AC into two congruent segments. AM and MC are the exact same length, okay, and they would be in a 1-to-1 ratio. So all that kind of fits together there. Okay, locating midpoints, again, this is just a different style of question. It says T is the midpoint of SV. Find the location of V. So they're saying T is the midpoint of S and V must be over here somewhere. And we got to find the location of V. So we know T is the midpoint of SV, and that means that T is halfway between S and V. In other words, we now know that ST and T to V, where it is over here, those are the same lengths. Okay, so if we find the length of ST, which we do by taking the absolute value of the difference of these two points, so I'm going -3 minus 10 absolute value. The absolute value of -3 plus -10. -3 plus -10 is -13. The absolute value of that is 13. So we know the distance now from S to T is 13 units. That means point V has got to be located 13 units to the right of T. So since we're going to move to the right of T, we're going to add 13 to T's point. And now we know V is going to be located at the point 23. You can look at it visually here. So we know -3 to 10 was 13 units. We need to go from 10 to the right another 13 units. That gets us to 23. And now that will make T the midpoint of SV. So we now know the location of V is 23. Okay? Pretty straightforward. We can throw in a little segment addition to go with the midpoint concepts. So here's a drawing, and let's look at the information given in the figure below. O is between M and P, and N is the midpoint of a segment MO. If N to O is 7 and M to P is 18, what is O to P? So let that set in a little bit. So we're told N is the midpoint of MO. Okay, that's where we're going to start this. What that tells us is the distance from M to N and N to O have to be the same. If N is the midpoint of MO, then it cuts it into two equal sections here. So if NO's length is 7, then MN has to have a length of 7. So we'll kind of redraw it here and put in some information that looks like this. So M to N is 7, N to O is 7, and I know M to P, the whole thing here, is 18. So it's a good visual of it. So how are we going to find O to P? Well, we're going to use segment addition. We know that M to N plus N to O plus O to P is equal to M to P. So substitute in what we know. We know 7 plus 7, so MN is 7, NO is 7, MP is 18. So now I know everything but OP, so I'm going to be able to solve for it in this little equation. Okay, 14 plus OP equals 18. Subtract 14 from both sides, OP is 4. So now we know the distance to O to P has to be 4, all using the midpoint concept and segment addition. All right, when we have to find a midpoint in the coordinate plane, it gets a little bit more complicated. All right, to calculate the midpoint of a segment in the coordinate plane, it's really the same idea, but we got to apply it to both of the variables. So we got to take the average of our x coordinates, x1 plus x2 divided by 2. That'll be my new x coordinate. And the average of the y's, y1 plus y2, that'll be my new y coordinate for the midpoint. So it's pretty straightforward. So let's say I had the coordinates of m here, or I want to find the coordinates of m, which represent the midpoint for this segment AC, where A is located at negative 2, 1. And I screwed that up. That should be C, but that's the other endpoint here, 8, 3. Not supposed to be a trick question. Well, that's a C. Okay, so basically I'm trying to find the midpoint between these 2 points. All right, well, how do we do it? We apply the midpoint formula. So I'm going to add together my 2 x coordinates, negative 2 plus 8, and divide that by 2. That'll be my new x coordinate. I'm going to add my y's, 1 plus 3 divided by 2. That's my new y coordinate. And now the rest is just simple math. So negative 2 plus 8 is 6 divided by 2. 1 plus 3 is 4 divided by 2. And we get 3, 2. So if we were to have a coordinate plane and plot those 2 points and connect them with a line segment, if I would go to the point 3, 2, that would put me right on the line segment, and it would put me exactly halfway between those 2 points. Okay, another example of this, just kind of now looking at it visually. All right, we're going to find the point of M, which is the midpoint for that joins the segments S and T. So we're trying to find the midpoint of ST here. We know it's about right here. We could take a guess, but we're not gonna. We're just gonna do it. Okay. So how do we find the midpoint? Add the x's together, divide by 2. Add the y coordinates together, divide by 2. That will give us the midpoint. So x coordinates 2 plus negative 6 divided by 2. Y coordinates 3 plus negative 1 divided by 2. Negative 4 divided by 2, 2 over 2. When I simplify, gives me negative 2, 1. Okay, so if I was to go over 2 up 1, that should put me right at the midpoint of ST. So I'm right on the line segment, and I'm right in the middle of it. Okay, so it's the average of the x, average of the y's. All right, now how do bisectors fit into this? Well, since a midpoint separates a segment into 2 congruent segments, we can also say that a midpoint bisects it. Bisects means to cut into 2 equal parts. So a midpoint bisects the segment. All right, a segment bisector is any any segment, line, plane, or point that bisects a segment. So what we're saying here is when a segment gets cut in half, it's whatever that passes through that segment has to pass through its midpoint. And now it could be a line that goes through it at the midpoint, a segment hits it at the midpoint, a plane cuts through it at this midpoint. But the bottom line, if it's going to bisect it, then it's got to pass through that line segment at its midpoint. Okay, so let's find some missing measures here. So we're asked to find the measure of RT if T is a midpoint of RQ. Okay, so here's the drawing that goes with it. So here's RQ, and they're telling us T is the midpoint of R to Q. All right, how do we handle that? Well, what do we know? T is a midpoint, so we know RT is equal to TQ. And if that's true, then the expression that represents RT has got to be equal to the expression that represents TQ. And now it's a math problem. Subtract 2x, add 5. Subtract 2x, I'll have 2x here. Add 5, I'll have 8 there. Divide each side by 2, x is 4. Now just be careful here because you're not done with the problem. Okay, you found the value of x, but it asks you to find the measure of RT. So we got to go back and finish up here. RT is 2x plus 3, and now we know x is 4. So 2 times 4 plus 3, RT is 11. So on a multiple choice test, they'll give you 4 early in the choices, like A or B, hoping that you just jump on that. Okay, you got to finish the problem. The real answer here is 11. All right. All right. That's pretty much it for midpoints and bisectors. The homework's pretty straightforward. I always add on here that if you go to your McGraw-Hill textbook site and go to this lesson, there's other examples that you can look at that you may find helpful. Obviously, there's a lot of material out there that you can use to help yourself. So, make sure you do so. All right. I'll let you get at it.